Hey, what's up, guys? This is Cheng here again. So let's take a look at another LeetCode problem. Since we already uploaded 2 problems today, so why not? Let's quickly check today's daily challenge. Problem number 19: remove nth node from end of list. Okay, so given like a head of a linked list, and you need to remove the nth node from the end. And follow up. Could you do this in one pass? So for example, right, if we have a linked list 1, 2, 3, 4, 5, and then we need to remove the second node from the last, which is the node 4. So after removing the node, the linked list becomes the 1, 2, 3, and 5. So first, a normal solution will be what? So since for the linked list, we can only traverse from one direction. So which means that even though we know the n is 2, but we don't know when should we stop. We want to know the loop stop it here, so that we can update the next pointer for this current node from pointing to 4 to pointing to 5. But to be able to know when we should stop, we have to know the entire length of this linked list. That's why the normal solutions we need to do a two pass. So for the first pass, we'll get the total length of this linked list, which is 5, right? And then we should subtract 2, and then subtract 1 again, which is 2. So the reason we subtract 1 is because we want to stop before this one, right? So if we start subtract 2, it means that we want to move the jump 3 times, right? So 1, 2, 3, it will be 4. But instead, we want to stop the one before the node we want to remove, that's why we need to do a -1. That's why, and then we can simply update the next pointer, right? So for the follow-up, right, what we really want to do is, can we do it in one pass? So to be able to do it in one pass, common technique in the linked list is the slow and fast pointer technique. So which means we're gonna have like slow and fast pointer, right? So which means we're gonna move the fast pointers n times first. So which means that at the beginning, after n times, for example, we have at the beginning, the slow and fast pointer, they are both pointing to the beginning of the nodes here, slow and fast. And then we're gonna move the fast pointer 2 times. So now the fast pointer is pointing to here, right? And then we continue moving the fast pointers to the end of the linked list, while on the second time, right, well, we move the slow and fast pointers together, and then by the time the fast pointer is reach the end of the linked list, the slow pointer will be pointing to the correct location, right? This is kind of obvious, right? Because since for fast pointers, we're moving through the entire array, the entire linked list. But for the slow pointers, we are moving the slow pointer n times less than the fast pointer. That's why when the fast pointer is reaching the end of the linked list, the slow pointer will be at the correct location, because it has like another n times traverse left, right? Yep. So that's the basic idea here. So for the coding, so we have slow equals to head, right? And then we have fast equals to head. So at first we need to move the fast pointer n times forward, okay? And then second, we're gonna move the fast pointer again, keep moving forward until we have reached the end, right? while we're also moving the slow pointer along with it. And then we return the, sorry, not return. Then we update slow pointer next equals to slow dot next dot next, right? And then we return the hat. But there's like a corner case we need to be careful, you know, which is the when n is equal to 5 in this case. When n equals to the length of the linked list, it means that we're removing the first element, the first node. And since we're doing this kind of a while fast next check here, you know, when n is equal to the length of the linked list, basically we're traversing the fast pointer has already pointing to the end of the linked list. In this case, it's going to be none, right? And if we just simply do a none dot next, it will basically arrow out, right? So which means we need to simply check if the fast, if not fast. This one means that, you know, removing, right, the first node. So how do we remove the first node, right? We simply return the head dot next, right? So this one, basically we're starting from here, right? Yeah, I think that's it, right? So if I run the code, accept it, and then it works, right? And one more thing, you know, is for this kind of while fast dot next or while fast, you know, in a linked list, it is called also always annoying to determine if we should use fast or fast dot next. So the reason we use fast dot next is because, you know, since we want the slow node stop before the node we're trying to remove, right? If we do a while fast, you know, then the slow node, the slow pointer will be pointing to the node we're trying to remove, not the node before it. You know, you can just try to run some examples, and you should be realize that why we're using the fast dot next in the while condition. Yeah, I guess that's it, right? I'll just stop here. Thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.